What innate is a lot?
All right, guys, quiet down. Guys, quiet. All right. So why don't you guys get your graphic calculators out? We're going to do this in the graphic calculator. And we're going to set it to polar mode. And we're going to reset the window. And we're going to do all these in the calculator. I'm going to do in the calculator also, even though I could use Desmos. I think we should get comfortable with using the calculator for this kind of stuff. So I'm going to pull up my calculator as well. Guys, stop talking about fantasy football. You guys suck at it. So just, especially Oscar. If you're 1-8, come on, dude.
You have like 120.
Okay, so go to mode, switch to polar. So you gotta go line 4, switch to polar, and stay in radian mode. Exactly. Mode, and line 4, switch to polar, and keep radian mode intact. And then go to window, and we'll switch it to 0. Well, 0 is my theta min. Let's make my theta max pi, so 3.14. If you hit second exponent button, that works. The theta step doesn't really matter. It's just how accurate you want it. I think that's fine. I don't know why it's 0.1308. Maybe I'll do 0.1. That's fine. X min will go -4 to 4, just so it's not too wide, and 4 for X max. X scale's fine. We'll go -3 to 3 for Y min and Y max. That should work. And Y scale's fine. Okay. So again, 0 to pi. What did you ask me, Audie?
For the X-Men.
No, it's on the notes too, from -4 to 4. Yeah, it has in brackets. And -3 to 3. Okay, so let's do cosine theta. So that is like saying, now if you think about the conversion again, R equals cos theta. R is like saying x over r. So r squared equals x. X squared plus y squared equals x. That's me a circle. In fact, x squared minus x plus y squared equals 0. If you complete the square, you get this. Plus 1/4. X minus half squared plus y squared equals 1/4. So that's what I expect to happen. Like a center at half 0 with a radius of half. I expect that to happen. His hit graph. Yeah, that's totally it, because that's x equals 1. So the center's up at half 0, and my radius is half. Makes sense. Okay. So we're totally cool with that. Good. Just cos, and then theta is where x is. The same place you'd use x is where theta will be.
So it's a radius of 1.
Right next to x, right below mode. You see mode, and then right below. No, don't do that. Actually, it wouldn't even know what to do with that. You have to actually go with the input button, which is it's right here. Right there. Okay. Let's fill up the notes, guys. Okay. So graph looks like this. What did you do, UV? Oh, that's cool, man. No, seriously, that's cool.
I didn't even know you could make a spiral.
You can. You can do a lot of things with it. So you get a circle, right? With diameter. Or with radius. I like to say radius. Radius of half. Center was half, comma 0. The diameter lies on the x-axis. So I'm just offering as much description as possible. Circle with radius of 1/2, centers at 1/2, comma 0, diameter lies on the x-axis. I think that's good enough. I don't know. Works for me. Okay. Now, without thinking too hard about it, what do you think r equals sine theta is going to look like? Yeah, so this case, I'll have a sine here, right? And that has to be y. That's y. That's y. So you still get this circle, but now it's gonna be x squared plus y squared minus 1, right? And then you have to complete the square to get that in.
So it's just rotating.
Totally. It's rotated by 90 degrees. 100%. So without actually going to the calculator or Desmos, we know we expect this, right? That's at 1. Again, another circle with radius of 1/2. Center, 0, 1/2. Now, in this case, the diameter lies on the y-axis. That's only a small difference. Okay. Or actually, let me take it back. If since the polar curve, what you really want to say is at theta equals pi over 2. And what we really want to say here is the polar axis. So actually, we should correct ourselves because we are now dealing with a polar coordinate system, not a rectangular coordinate system. So the x-axis, that's actually called the polar axis. That's theta equals 0, which is called the polar axis. Theta equals pi over 2, that's like the y-axis. So, okay, we're okay with that? Do those make sense? How those work? Okay. Now for the next one, let's actually do that in the calculator.
What? You want to say like where the center is, given the polar coordinate?
Yeah, I would. Yeah. Or what you could do is you can say where it passes through also. Like it passes through 0, 0. That could work. Yeah. Actually, I probably should say it like that. That's probably a better way of saying it. Okay, guys, quiet, please. Let's move on. Okay. So 2 cos theta. So it's a bigger radius, right? But if I were to make that negative, let's insert a negative. It goes the other direction, right? So let's take care of that now. Bless you.
Bless you.
Okay, so again, another circle. Center is now at 1, 0. Diameter lies on polar axis. Radius is 1 now. And then here, same as above, but it's on the left side of the polar axis. And I think you guys kind of know what's going to happen here, right? Oh yeah, all right, good.
Is it flipping to the left because you're using,
The negative.
like, normally when you use negative, it flips to the y, like it flips over the x-axis. But here, you're flipping over the y-axis because it's
180 degree rotation. That's what it is. When we do a negative, it's a 180 rotation.
Thank you.
Yeah, so that's at 3. That's at -3. And again, they're circles. You get the idea. The diameter, I'll say the diameter. Diameter is 3, so radius. Both pass through the origin. Yeah, go ahead. Yeah, but that's a 180 rotation. Yeah, yeah. And this is yeah, this is above the pole. And that's below the pole. Remember, the pole is like the origin. That's a pole. It's like the origin. So in general, if r equals k cos theta, the diameter equals absolute K. It's circle and lies on the polar axis if K is greater than 0, or left side of polar axis if K is less than 0. And also it contains 0, 0. So that's what we can expect generally for the stuff. But for K sine theta, again, it's another circle. Diameter is absolute K. Lies on theta equals pi over 2. And it's above pole if K is greater than 0. Below pole if K is less than 0. And passes through 0, 0. That's a lot of information I shared with you guys, but they're just circles we see algebraically, right? You see it there, that's not hard. Okay, all's good there? Okay, once you guys do this in your table groups, work on part B, write the rectangular equations in terms of X and Y for those two, which you guys should already have practice with because they asked in the last homework, right? So take some time, do part B. I'm going to do it as well. We'll share in about 2 or 3 minutes, which shouldn't take very long. Then move on to example 6.
Ours.
But Oscar, our time, same thing. Our time is cosine with X.
You get the same.
Yeah. Is that right? Is that right?
I understand why we need to learn conics.
Oh, come on.
Oscar, I have X squared plus Y squared over 2X equals 1.
I got X minus 1 squared.
Why'd you divide it?
All right, here are my answers.
Looks like
Oh. I thought I froze my screen. All right, here we go. Here are the answers. Hopefully you guys got the same thing. We're okay. Take a little more time if you need it.
Wait, so
You could divide it, but then it's not.
All's good?
It's like 15.
Yeah. Oh, sorry, is that?
There's Oscar and I were debating. What 5 square?
That's correct. Yeah. What did Oscar think?
Oh, it's the same thing.
Yeah, of course. Yeah. So what's the debate about? Okay. Oh, got it. Okay. All right. You be good?
Or 1.5 square.
The end of the negative cosine theta does not, like, the edge is not at 0, 0, like 0, 0 is the vertex.
I guess in this case it would not be.
if it was just
Yeah, or the pole, right? Because -3 halves. 3 halves. Wait, no. It would be
Half
still.
of 3 halves of 3 quarters.
Yeah. Half of, so you take the square root.
Oh, right.
Yeah, no, it's still be touching the pole. Yeah. All right, guys, we're okay. Let's move on. Example 6. Here we go. All right, consider the following polar equation. Basically, we learned from example 5. Describe the graph. So yeah, so obviously, mostly obviously, but we know it's gonna be a circle. Diameter will be 6. Lies on the polar axis. And passes. So we know it's gonna look kind of like this, right? We expect that to happen. So what we're going to do is we're just going to graph this by hand just to make sure we fully understand how polar graphs are supposed to be generated. So we've kind of done the algebra already. Like we understand algebraically what's happening. Like, hey, let's multiply both sides by r. X squared plus y squared equals 6x. Bring the 6x over to the left side. Blah 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 blah. You know, do the clean the square. But if I were to actually do this by hand, like this will be theta. This would be r. And if I do a few theta values, like the first quadrant for sure, and then all the axes, or oh, we're going from 0 to pi. Okay, so there we go. And just evaluate. It's not hard. That's gonna be 6. That's gonna be 0 and -6. So I can get that out of the way. So if theta is 0, you raise to 6. And then pi over 2, comma 0. That would be actually right there, because you don't have a radius. And pi, comma -6. So here's 6, but it has to jump over, so it gets back over here again. So this point is both 0, 6 and pi, comma -6. So some of these points actually serve more than one set of coordinates. The point to the far right can be both 0, 6 and pi -6. Now pi over 6, remember that's gonna be 6 times.
So then pi over 6 and pi over 6 would be the same if one's positive and negative.
Yeah, and actually I did that wrong. That's supposed to be root 3 over 2. My bad. I was doing tangent. And -3 root 3. And this would be 3 root 2 and -3 root 2. And this would be 3 and -3. Because cosine of pi over 3 is 1/2. And 2 pi over 3 is -1/2. So pi over 4, 3 root 3 is roughly 5.2. 3 root 2 is roughly 4.2. So I did pi over 6 and about 5 point something. And then pi over 4 and like 4 point something. And then pi over 3, comma 3. Yeah, so you see you have the top half of the circle there. And then if I did 2 pi over 3, -3, so 2 pi over 3, -3, so that's right here, but it's got to jump. Let's place tricks in your eyes, this stuff here. It's a little frustrating.
Because they're just opposite.
Yeah, totally. Yep. Yeah, but then we got to keep going and do a bit more. And there you go. So that's just kind of like the algorithm that's the calculus using. It's computing all these values and then generating the curve. Andy, go ahead. No, it doesn't matter. But the theta is usually the input and the r is usually the output. So that's by habit. Yeah, for the most part. Yeah, because you're doing r in terms of theta. if that helps. So, but it wouldn't matter. I mean, it's up to you. Yeah, Duke, and then I'll get a question too. Hmm? Yep. What about transformation? Oh yeah, it is a transformation. Yeah, totally. Yeah, it is. Yeah, it is like a transformation in some way. Sure. Mhm. I mean, actually, it could be more thought as a dilation, I guess, I suppose too, because it is getting, you are stretching it. And you know, a number in front of cosine theta is a vertical change. I mean, vertical stretch. I mean, it's an amplitude. I mean, if you want to think in terms of rectangular coordinates, going back to it. Sure, sure. Yeah, but I mean, you don't have to think too hard about that. I mean, it's really just more. Yeah, I mean, if you want to make that conjecture, go ahead. So let's go back to converting again. All right. So I'll give you guys a moment to do 7A and B in your table groups, and then we'll talk about it. I'll freeze my screen. I promise I'll have it frozen. There we go. Oh boy, let's see here. And it's up to you. You can convert for X and Y right away, or you can expand first and combine afterwards.
Yeah. Cosine X over R. X equals cosine times R. Got a good one.
Yep, there we go. So I decided just to expand and then convert and substitute later. You can substitute from the beginning too. Substitute.
I think.
Boom, I got that same answer.
Yeah, make mistakes.
Yeah.
I did?
I think the X was.
Oh, you're right. Yikes. Wow. Thank you, Brooke, for catching that. Ah. Hold on.
Yeah, I got the same answer. Oh no, I got it.
Yeah, thank you for catching that, Brooke. Okay, there we go. Cool. Okay, questions? No? All right, let's keep moving. Sample 8. Okay, graph the following pairs equation on your calculator. Oh, you want to go back?
Yeah, I think. Go.
Okay.
Oh, it's too late now.
All right. So graph the following in your equation. Yeah. I'm sorry, graph the following equations in your calculator. What do you notice? All right, so let's look at 3 cos theta and then 3 cos theta minus pi over 4. A little self-discovery to see what happens there with that. So go back to the calculator. Three cos theta minus, I'll do 0.25 pi, same thing.
You have my grades.
No, I don't.
Whoa, what happened? Whoa. Wait, what? Oh, that was dumb. Yeah, that's silly of me. Here we go. Okay, so it looks like there's a vertical or rotation, actually. So it's a little weird, but what happens is that the graph is rotated. Guys, quiet, please. By pi over 4. And it went clockwise. It went counterclockwise, as we would expect. So you took this graph, right, with a diameter of 3, and it got rotated kind of like that. So going back to the calculator again, you can see the second circle had a bit of a rotation there. So it's still touching 0, 0, but it's a rotation as a result. And by the way, if I were to do this, hopefully you guys recognize what's happening here. What if I did 0.5 pi? Because what is cosine of theta minus half pi? Sine, it's an identity, right? Because they're complements to each other, should have to 90 degrees. So exactly, right, yes. Right. Everything comes full circle. That was an intended pun. Okay, no, okay. You guys don't get it. That's fine. Okay, thanks. All right. Okay. It wasn't a good one. All right. Yeah, she gets it now. Okay, good. All right. Okay. Yeah, go ahead. So next up, let's do it for sine, right? 3 sine theta. So it's going to rotate 60 degrees the other direction. Okay.
Because they rotated.
Yeah, rotates 60 degrees. So in this case, it's rotated negative pi over 3, exactly.
It's like,
So it's rotated clockwise by pi.
Or say negative pi over 3. Or you can say that also. Because the implication when it's a negative angle is going to be clockwise. Okay. Okay. So in general, what happens? Rotate by an angle. Okay, guys, stop. All right. Okay. Let's consider a few more situations. So let's talk about secant and cosecant. Okay, for secant. Well, now we know it's. I'll do it on the board. We know it's happening.
Yeah, so R equals 1 over cos theta. So R is 1 over X. Sorry, X over R. So R is X. R equals R over X. 1 equals 1 over X. Basically, X equals 1. Right? If you were to solve it, that's what would happen.
So that's what we expect to happen. X equals 1, right? So, but we'll go and graph it anyway. To do secant, just do 1 over cosine, right? A little frustrating here. Yeah, just 1 over cosine X. And it's kind of weird. It doesn't like do it all. It just goes up and down. It's just the algorithm it uses because it's going from 0 to 2 pi, or whatever you did, 0 to pi. So anywho, that's just I'll kind of just finish the time, just tell you how these will look. So y equals 1. This be x equals 2. And this be y equals 4. This would be x equals negative 2. And this would be y equals negative 4. So in general, this will always be x equals k and y equals k. So you're getting a lot of the tools right now, like a lot of the fundamentals. We're going to really expand on this on Friday and next week. Like we're going to start seeing like really crazy stuff, like rose petals and spirals and cardioids look like a heart. Like you're going to really make some really cool stuff. You can let your artistic creativity come out.
Christmas project.
We should do that actually. I think we should.
No.
Why not? Okay.
Keep just making the art line. It's art, we're releasing it.
All right, let's keep going, guys.
Yeah, it's our final.
All right.
This is like the test.
So, guys, quiet. Why don't you guys take some time and do part B of example 9 and parts A, B, and C of example 10. I'll give you guys about 4 or 5 minutes to kind of convert. So we're going to be converting in part B of example 9 from polar to rectangular. And then example 10, A, B, and C, we're going to go from rectangular to polar. I'll give you guys a few minutes to do that, and I will do that myself.
Oh.
Or not with that, it just looks like y equals that.
Because every single point would be true.
No,
So it'd be a
there's no.
y is equal to y. Anything you put.
If there's no on it, then you can't find it. It'd be one direction. It's a lot.
A line along the.
Yes.
There's no it's not gonna be.
Isolate R if you can. Yeah, I would.
It's so annoying.
Yeah, these are pretty easy, guys.
Wait, wouldn't it be 8 secant theta, not 8 over secant theta?
You are correct.
So,
Brooke, you've corrected me twice now. This is amazing. I know. Okay, thank you, Brooke, for doing that. And then this one here is kind of crazy.
Have been solid.
Okay, obliques are just a made up word.
No, they've been solid.
Made up by liberal.
You got really bad. No, you made it.
Obliques are not real, but
Love them.
I like to see the data of my sports.
All right.
wait, what else are you supposed to do here? Like, realistically, there's nothing else to do.
Wait,
That's like a yucky equation.
this is converting us all.
You're not-
even possible?
Oh.
It's just to help you guys get more fluent with going back and forth between the two forms. That's all.
Like,
Look.
would we ever be asked to like graph that third?
Yeah, totally. Yeah,
How would you?
you convert.
Oh,
You
No,
graph
but
two
like-
x minus 3y.
It's just a recognition thing.
oh,
all.
okay, that's smart.
Okay, guys, questions on this before we wrap up the notes? We got about 6 more minutes left for class, or 5 more minutes. So I should be able to wrap up example 11 in a couple minutes and we'll be done. We're okay? All right. Okay, let's wrap this up. We'll be done in a couple minutes. Example 11. All right. So now we know what's happening, right? Like we know this is a rotation. Like, okay, that's rotate 2 pi over 3. That's rotate -5 pi over 6. It's the same thing. So you just rotate by k. And in general, same thing here. Just in general, always. I mean, I didn't work it out just in the interest of time. But if I were to plug in 3 secant theta in my calculator Desmos, plug in 3 secant theta minus 2 pi over 3 in my calculator Desmos, you'll see that kind of rotation happening. So that's all.
So the A doesn't matter, it won't be like.
No,
K over A.
No, won't matter.
Oh.
Just K. Now, homework wise, the packet I gave you guys on Monday, that like, so I gave you 2 packets right at the notes, which we've been working out of. That homework packet's still not going to apply yet, not until Friday. So most likely what I'll probably do, I might just assign more stuff from here. So this textbook stuff, I might assign more stuff from there. I'll have a chance in the next period to update the homework. So it's just be a worksheet I'll put up to have you guys work on. So I think that is it for today.